Now we're going to look at this worksheet 1.51a. We're going to look at domain and range of graphs, tables, and charts and tell if it's a function or not. Now I'm going to look at problem number 3 first. So when I look at this right here, I want to find the domain. So the first thing I see, which is the domain, which is your x-axis. So this is your domain. We're going to see how wide it is. So it starts right here at 0. And it comes all the way over here to this number 6. Here's 0. 1, 2, 3, 4, 5, 6. So we know it goes from 0 to 6. We're looking at the y-axis, and so we're going to put an x in the middle, and then we're going to put the inequality less than or equal, because it goes from 0 to 6. Now I'm going to look at the range, and when I look at the range, I'm seeing how tall it is. So I'll look at this and I see here's the lowest point, which is at a -3. And the highest point of this is at a +3. So I'm going to put the +3 here. We're looking at the y-axis, which is the range. So we're going to put a y here, and it goes from a -3 all the way up to a 3. So we're going to put less than or equal, less than or equal. Now, if I were to check to see if it's a function or not, I'm going to draw a vertical line, and I see it's going through 1, 2 points at a time. So it is not a function. Now, we're going to back up to problem number 1. On problem number 1, we're looking at range and the domain right here. So when I look at this right here, I see that I have arrows right here on that line. That means that when we're looking at the domain, which is your x, that line does not stop. It goes on forever and ever and ever and ever and ever. And so we can say it is all real numbers. Another way to say this is it goes from -infinity, over here is -infinity, less than x, and it comes over here to +infinity. So we're going to put less than +infinity. So this one is your domain. So it goes from a -infinity to a +infinity. Infinity is less than x, less than a +infinity, or all real numbers. Now, when we look at range, though, we see that on range, we have the highest point and the lowest point right here. This one is the range, which you're talking about the y-axis. So now, since it does have a definite cutoff space, we're going to go ahead and put y less than or equal, less than or equal. Make sure that you always put the smaller number on the left-hand side, and I see that it comes down here to a -1. The lowest point is a -1. So I put a -1 right here. The highest point is at 5. So I have 0, 1, 2, 3, 4, 5. Now I'm going to draw a vertical line, and I'm going to see, is it a function? So when I draw a vertical line right here, I see it's only going through that figure one time. So yes, it is a function. Now look down here at number 5. Number 5, we're going to look at domain and range also. Let's go ahead and see if it is a function. Just answer that right off. So I'm going to draw a vertical line through here, and I see it's crossing right here and right here more than one time on the vertical line. So no, it is not a function. It fails the vertical line test. Now let's go back and check for the domain. So remember, the domain is talking about the x-axis. So I go down here and I see it's right here at 1, and then it goes to a 5. So that's the widest figure. It has a definite stopping point. So we're going to put x less than or equal, less than or equal. Now just go back and you're going to put in these numbers right here. The smallest number is a 1. The biggest number is a 5. So it measures from 1 to 5, and you read it as 1 is less than or equal to x, less than or equal to 5. Now, I'm going to go back and I'm going to look at the range. I see I want the lowest point and the highest point. So this is the range, which is the y. Now, when I look at this right here, I see it does have a definite stopping point. So we're going to put y is less than or equal, less than or equal. So it's the lowest point right here is at a 3. The highest point is at a 5. So we have 3 is less than or equal to 5. 3 is less than or equal to y, less than or equal to 5. Always make sure that when you're reading this, 3 is less than 5. Make sure you put it on the correct side. Now, look down here at number 9. On number 9, you see that we have to find the range. So we're going to look first off, let's look at to see if it is a function. So I'm going to draw a vertical line, and I see it's only going through one point at a time, so we say, yes, it is a function. Now, when I look at this right here, I'm going to take that line back out, the vertical line test, and I'm going to measure how wide it is. So I'm going from here to here. But when I look at this figure has arrows on it. That means it keeps on going in this direction forever and ever and ever and ever and ever. So we cannot measure how wide it is. This one would be all real numbers, or we can write it as negative infinity less than x less than a positive infinity. We do not put less than or equal on this because it does not have a stopping point. It goes on forever and ever in that direction. Now, when we look at when we're looking at number 9 at the range, we see that on the range that it does have a definite stopping point. If I were to come up and with my pencil coming this way, I see that I run into it right here. So this one does not have a stopping point. The lowest point is a negative infinity, less than, and we're looking at the y-axis. However, when I look at this right here, the highest point, it does have a definite stopping point. And remember, we're looking at the range. So I can say it does definitely stop at 3. So the range right here is negative infinity less than x less than or equal to 3. Because remember, when you're looking at this part right here, it goes on and on forever and ever and ever. So I'm going to take this off so that you can go back and you can see it without me marking all over it. So this is the range when you're looking at going from how tall it is, and it keeps on going forever and ever and ever. Now, look at number 10. Number 10, if we were to go ahead and do the vertical line test, I see it's only going through one point at a time on that vertical line, so we say, yes, this is a function. Now, I'm going to take this line off, and then I'm going to see how wide it is. And when I look at how wide it is, I see that we've taken a picture right here, because we're looking for a domain. Now think about if you're taking a picture, using your camera. Notice that this right here just got cut off. And over here on the other side, it also just got cut off. You can't see the arrow because it did not, it continues on and on and on. So when I look at this right here, I see that this would be what would be left on it. And so since it does not have a definite stopping point, when you're looking at the domain, how wide it is, then we say that this one is, the domain is all real numbers. And when I look at the range, now the range is going to look at how tall it is. What's the lowest point? What's the highest point? I see the lowest point is right here. So I could say the lowest point is at a -2, and it does have a definite stopping point. So we're going to put less than or equal, and we're looking at the y, which is the range. And it definitely has a stopping point right here. So we see that it is less than or equal to 2. So that does have a definite stopping point. Now, look down here. Look at number 11. On number 11, you see that the first thing we're going to do is the vertical line test. So if I were to do the vertical line test, I see there's only 1 point on that vertical line test, and so we say yes, it is a function. Now, I'm going to look to see if I can measure how wide it is, and I see that this right here, there's an arrow. So if I were to come in from this direction or this direction, this arrow would keep on going. That red arrow, that red line, would keep on going forever and ever and ever. So they would run into each other. So this one does, when we're looking at domain, how wide it is, I see that it goes on and on and on, and there's no way that we can measure how wide it is. So we're going to say it goes from negative infinity to infinity, or we could say all real numbers. Now, when we're looking at range, notice that that line still keeps on going forever and ever and ever. So I'm going to look at the range, which is the y-axis. And remember, this line continues on and on in both directions forever and ever and ever. So when I look at it and I come down here to the bottom, I see that I am not able to tell where it ends or what's the lowest point, because it goes on forever and ever and ever. So I can say now negative infinity less than y, since we're talking about the range, and over here when I come down from this direction from the top, you see that it does not have a definite stopping point. It continues on and on forever and ever in both directions. So we can say it's a negative infinity less than y less than a positive infinity. Or I could say all real numbers. Okay? Now, when I look at this problem right here, number 16. On number 16, we're going to measure the domain first, which is the x-axis. So since this is the x-axis, and I see that this line continues on and on forever and ever, and it keeps getting wider and wider and wider, we see there's no way to tell how wide it will be. So it is a negative infinity less than x less than a positive infinity, because it's all real numbers. It goes on and on and on. So it just keeps getting wider and wider and wider. Now, when I'm looking at the range, so I come down here to the bottom. Remember, the range is the y-axis. So when I'm looking at the range and I see, that arrow tells me it goes on and on forever and ever and ever. So there's no way I can see what the lowest point is. So we're going to say a negative infinity less than y. However, when I look over here, there is a definite stopping point right here. It stops at 1, 2, 3. So we have 1, 2, 3, 3.5. Let's say 3.5 right here. And so this one, we cannot see how wide it is and at the bottom, but we can at the top. There's a definite stopping point. So now I'm going to check for the vertical line test. And when I check for the vertical line test, I see that this right here, when I use the vertical line test, there's only 1 point on that line. So yes, it is a function. Now, remember, when we're looking at problems like number 13, make sure that you write these problems out on the side. So like this one would be negative 3, 1. This is a negative 3, 1, 2, 3, 3. This one would be a 2, 4. And this point is at 1, 2, 3, 3, 1, 2, 3, 3. And this point right here is at 4, negative 2. Now, when I look at this right here, I'm going to check, is this a function? So I look at this right here and I see, when I draw a vertical line, it's going through this point, and let me change colors so it will show up. Okay, let's change, nope, not that blue. So let's change this one. So here's this point here and this point here. I see that I have 2 points on one vertical line, so it is not a function. Now, I'm going to go ahead and I'm going to come up with my domain right here. Now, since this is a discrete graph right here, we have to write individual points. These other graphs that we did right here, you see, is continuous. They're not dots. So we write these like this. Now, same thing on number 1. This is continuous graph. It is not discrete graph. So we have to write this just like we just did right here on domain and range. It is a continuous graph. Same thing on number 3. It is continuous graph. You do not write individual points. You have to write them just like we have domain and range right here. Now, also, number 11 and 10 are both continuous graphs. So since they are continuous graphs, we have to write it as we did right here with the less than or equal on both of those. Now, when you look at number 13, since it's the individual points, it is a discrete graph. You're going to go through here and you're going to write them individually. So I'm going to start with my smallest number right here. The number that's farthest from the 0 on the left-hand side is the smallest one. If the number repeats, then we only write it down one time. So I see that I have a negative 3, negative 3. So we're just going to write this down one time. And I'm going to go ahead and mark it out because I've used it. Now I'll come over here to these other points. I see how the number 2, 3, and 4. Those are in order. 2, 3, 4. Now, I have used those. Come over here to the other side, and because these, you just found out the x and y. Remember, when we're looking at domain, we're looking at the x, and when we're looking at the range, we're looking at the y point. So, I'm going to take these now, and I'm going to put these in order. I see how the numbers 3, 1, 4, 3, negative 2. Well, I see negative 2 is the smallest number, so I'm going to put a negative 2 first. Then, so I'm going to mark that out, and then I come around here and I see that 1 is the next smallest number. We're getting bigger as we're going from left to right. Then we have 3, we have 2 of number 3, but I'm just going to write it down one time. And now we have number 4. I have just written these in order. So this is how you're going to work it, a discrete graph. Same thing on number 14. As you see on number 14, you see that this is the domain and this is the range. So all of these I'm going to put right here, which is your x. I'm going to put them in order, and as you can see, they're already in order. Do not repeat any if they repeat. So this is it. Now, when I look over here at the other side, I see the range right here. And since these are the ranges, I'm going to take these right here and write them in order. And when I write them in order, I see the smallest number right here is a 2. So I'm going to put a 2 first. Then I go to a 3. And then I have 2 4s, so I'm going to put just 1 4 down and then 1 5. Now, I have them in order. At this point, we have to check to see if it is a function or not. So I'm going to look over here at the x-axis only. It does not matter what the y-axis says. So since we're only looking at the x-axis, as I look at all these numbers are the x coordinates right here. I see that we only have a -3, -2, -1, 2, and 3. None of these numbers repeat. And no, -3 and a +3 are not the same numbers. -2 and +2 are not the same numbers. So one's positive, one's negative, so none of those repeat. And so we're going to say yes, and that was wrong. And we're going to say yes, it is a function. So we're going to put yes, it is a function. Same thing with 15a and b. So when I look at this right here, I can put dr, 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 dr. And I can, since these are individual points, this would be considered discrete. Same thing as 14. These are both discrete points. So I'm going to write them as discrete points. Now I'm going to look, I see I have a 5, a 2, a 9, and a 4. I'm going to put these in order. So I'm going to put a 2 first, smallest number, mark it out. Then I have a 4, mark it out. A 5, mark it out. And a 9, mark it out. And you are finished. Now we're going to come over here and we're going to look at the ranges. So notice that I have a 9, 9, 9, 9. So I'm going to simply just write it one time. So I'll look at all of this, and now I have to determine if this is a function or not. I'm going to look at 5, 2, 9, and 4. And I see none of those repeat, so this is, yes, it is a function. Like I said, it does not matter about the range. The range, as you can see, can be the same number all the way across, and it could still be a function, which is this. Now I want you to finish the rest of this worksheet right here. And I want you to, if you're a distant learner, you'll submit it into me. And in-class learners, you'll submit it into me in class. Distant learners, you have directions and you kid them.